Good morning students, I am Ashmi Prasad and creator of this channel Digital Generation. This channel is regarding chapter wise preparation for both ICSE and CBSE students. I hope you will get best knowledge and explanation from this channel. Today I am going to teach about periodic table in chemistry of class 10. And our today's topic is why the properties of elements vary in period and in a group. And for this we have divided the periodic table into categories: characteristic of elements in a period and characteristic of elements in a group. So first we will study about the characteristics of elements in a period. So from going from left to right side of the period, we have seen there is a variation in properties of the elements like valence electrons, valency, size of the atom, metallic character, chemical reactivity and nature of the oxides. Now we will study them one by one. So first we will take the valence electron. On moving from left to right side of the period, we have seen that the valence electron increases from 1 to 8. For example, the first element of the period has 1 valence electron, whereas the last element or 8th element has the 8 valence electron. We will take the example of the third period of the periodic table. This is sodium, then magnesium, then aluminium, then silicon, then comes phosphorus, sulfur, chlorine and argon. This is the third period of the periodic table. And now we will see how the valence electron varies from first element to the last element. We have to know the atomic number of this element. The atomic number of sodium is 11, then comes 12, 13, 14, 15, 16, 17 and 18. So it is clear that the elements in a period have consecutive atomic number, and by knowing the atomic number we can get the electronic configuration of the elements. The electronic configuration of sodium will be 2, 8, 1, magnesium 2, 8, 2, aluminium 2, 8, 3, silicon 2, 8, 4, phosphorus 2, 8, 5, sulfur 2, 8, 6, chlorine 2, 8, 7 and argon 2, 8, 8. Thus we can see that the valence electrons are also increasing consecutively. And the first element, that is sodium or period third, has 1 valence electron, and the last element argon has 8 valence electron. Chlorine has 7 valence electron. Thus it is clear that valence electron also increases consecutively in a periodic table. Now we will see the valency of the elements in a period. On going from left to right side of the period, we will see that the valency first increases up to 4 and then decreases to 0. So the valency of sodium is 1, valence of magnesium 2, aluminum 3, silicon 4, phosphorus 3, sulfur 2, chlorine 1 and argon 0. Now how can we get the valency of an element? The valency of an element can be determined by the presence of valence electrons present in that atom of the element. Again, the tendency of an element to lose or gain electrons determines the valency of that element. So in third period we will see that the valence electron of sodium is 1, magnesium has 2, aluminum has 3, silicon has 4, phosphorus has 5, sulfur has 6, chlorine has 7 and argon has 8. These are the valence electrons that are present in the outermost cell of the element. Now in case of sodium, sodium has 1 valence electron. So sodium easily loses 1 valence electron and forms positively charged ion. Sodium will give 1 electron and will form sodium plus. Again, magnesium will also give off 2 electrons and will form magnesium 2 plus. So the valence of sodium will be 1, because we have said that the number of electrons lost or gained by an element determines its valency. So the valence of sodium is 1. Again, the valency of magnesium is 2. Valency of aluminum is 3. The valency of silicon is 4. Now from phosphorus. Phosphorus has valence electron 5. Phosphorus has valence electron as 5. So it is easy for phosphorus to gain 3 electrons and achieve nearest inert gas electronic configuration. So phosphorus will gain 3 electrons. P will gain 3 electrons and will form. Thus, as phosphorus gains 3 electrons, so its octet of nearest inert gas is complete. So the valency of phosphorus will be 3. Again, the valency of sulfur. The valence electron of sulfur is 6. Sulfur has 6 valence electrons. So sulfur will gain 2 electrons from other elements and will achieve the nearest inert gas electronic configuration. The valence of sulfur is 2. Again, the chlorine has 7 valence electrons. So chlorine will accept 1 electrons from other elements and will form negatively charged ion. Thus, the valency of chlorine is 1. So we have seen that the valency of the elements in a period first increases up to 4 and then decreases up to 0. Now, what is the difference between magnesium and sulfur? We have seen that the valency of magnesium is 2 and the valency of sulfur is also 2. Again, the valency of sodium is 1 and the valency of chlorine is 1. Now, what will be the difference? Because both of them have the same valency. The difference is that magnesium loses 2 electrons and forms positively charged ion. So, magnesium is a metal, whereas sulfur gains 2 electrons and forms negatively charged ion. And thus, the valency of sulfur is also 2, but sulfur is a non-metal. Now, we will discuss about the size of the atom in a period. Our third topic is size of the atom, or we can say atomic size. The size of the atom or atomic size depends upon the radius of the atom. What is the radius of the atom? The distance between the nucleus and the last electron cell or valence cell is known as the radius of the atom. So atomic size refers to the radius of the atom. Atomic radius is expressed in picometer. Now in a period we will see that the atomic size or atomic radius of the element present will become smaller. For example, in the third period of the periodic table, the first element sodium has the biggest atomic size, whereas the chlorine has the smallest atomic size. We will not consider these group 18 elements because these are known as the inert gas or unreactive gas. The size of these inert gases are comparatively bigger than that of group 17 elements. So we will consider up to these elements, chlorine. So we will see that in a group, the size of the atom decreases from element 1 to element 7. So the element on the extreme left will have the biggest atomic size, whereas the element on the extreme right will have the smallest atomic size. For example, in period third of the periodic table, sodium has the biggest atomic size, whereas chlorine has the smallest atomic size. And now we will explain why this happens. On moving from left to right side of the periodic table, we know that atomic number increases, and as atomic number increases, so the number of protons and electrons also increases, and the extra electrons are added in the valence shell. So the positive charge of the nucleus increases considerably from left side to right side. As the positive charge of the nucleus increases from left to right side of the period, so the valence electrons are attracted more strongly by the nucleus. So sodium is the biggest, then comes magnesium, then comes aluminium, then comes silicon, then comes sulfur, then comes chlorine. So we can see in third period, sodium has atomic radius of 186 picometer, whereas chlorine has atomic radius of 99 picometer. So the size of the atom decreases as we move from left to right side of the period. Now we will study about the metallic character in a period. The metallic character of the period decreases, whereas the non-metallic character increases in a period. So the element on the extreme left will be most metallic in character, whereas the element on the extreme right will be most non-metallic in character. Thus in period third of the periodic table, we can see that sodium is most metallic in nature, whereas chlorine is most non-metallic in nature. Metallic character can also be denoted by electropositivity because metal loses electrons and forms positively charged ion. So we can say that electropositivity of the elements decreases as we move in a period, whereas the electronegativity of the non-metal increases in a period. Now we will explain why this happens in a period. We know that in a period, the nuclear charge or positive charge of the atom increases, and as the positive charge increases, so the valence electrons are more strongly attracted by the nucleus. So it becomes very difficult for the metal to lose electron and form positively charged ion, and thus the metallic characteristic of the metal or the electropositivity of the metal decreases in a period. On the other hand, as the nuclear positive charge increases, so it is easier to accept or gain electrons. So the electronegativity or non-metallic character increases in a period. Thus, in period third of the periodic table, sodium is most metallic in nature or most electropositive, then magnesium and aluminium, whereas chlorine is most electronegative element in this period, then sulfur and phosphorus. Now we will study about the chemical reactivity of elements in a period. Chemical reactivity. On moving from left to right side of the period, we will see that the chemical reactivity first decreases and then again it increases, and the chemical reactivity of the elements depends on the valence electrons present in it. So in third period of the periodic table, we will see that sodium is very reactive. It is more reactive than magnesium, whereas magnesium is more reactive than aluminium. Silicon is least reactive. Again, phosphorus is more reactive than silicon but less reactive than sulfur. Sulfur is more reactive than phosphorus. Again, chlorine is most reactive among the non-metal. Chlorine is more reactive than sulfur and phosphorus. So chlorine is also very reactive. Thus we will see that in this third period, sodium is very reactive and chlorine is very reactive. Silicon is less reactive, whereas the reactivity decreases to magnesium and aluminium, and again here the reactivity increases from phosphorus to sulfur and then to chlorine. Now we will explain why this happens. Because we know as the positive charge of the nucleus increases as we move from left to right side of the period, so the force of attraction of the nucleus and the valence electrons also increases. So it becomes very difficult for the metal to lose electron and take part in the chemical reaction. Thus, it becomes easier for sodium to lose one electron and take part in the chemical reaction because the valence electron of sodium is 1. Again, magnesium has 2 valence electrons, so magnesium has to lose 2 electrons and form positively charged to react with other substances, whereas aluminium has 3 valence electrons. So it is very difficult for aluminium to lose 3 electrons and form positively charged ion and then react with other substance. Thus we see the sodium reacts vigorously with water and forms sodium hydroxide and hydrogen because it has to lose only 1 electron, whereas magnesium reacts with water on heating, whereas aluminium reacts very slowly with water. Silicon is least reactive and silicon is also known as metalloid. Then phosphorus. So phosphorus has to gain 3 electrons to take part in the reaction, whereas sulfur has to gain 2 electrons to take part in the reaction. So it is difficult to gain 3 electrons than to gain 2 electrons, whereas chlorine has to gain only 1 electron. It is very easy for the chlorine to gain 1 electron and take part in the chemical reaction. So chlorine is very reactive and sodium is very reactive in the third period of the periodic table. Thus we can conclude that the chemical reactivity of the elements in a period first decreases and then again increases, and this chemical reactivity mainly depends on the valence electron, the tendency to lose or gain electron. If it can lose electron very easily, then it will take part in the chemical reaction very actively, whereas if it is difficult for the element to lose or gain electron, then it will take part slowly in the chemical reactivity. Thus it totally depends upon the valence electron. Now we will study about the nature of oxides of elements in a period. On moving from left to right side of the period, the nature of oxide changes. The nature of basic oxides of the element decreases, whereas the nature of acidic oxide of the element increases. For example, the first element of every period will form an oxide which will be most basic in nature, whereas the last element or group 17 elements will form acidic oxide which will be highly reactive. So the first element forms strong basic oxide and halogen group element forms strong acidic oxide. Basic oxide of magnesium is less strong than sodium, whereas aluminium and silicon forms amphoteric oxide. The acidic oxide of phosphorus is reactive, but it is comparatively less stronger than that of sulfur. Sulfur forms acidic oxide which is stronger than that of the phosphorus, and chlorine forms acidic oxide which is highly reactive. Thus we can say that in a period the nature of basic oxide decreases, whereas the nature of acidic oxide increases in a period. Thank you for watching my video, and if you find my video useful, please do like and share my video and subscribe my channel to get the latest update of my videos. And if you have any doubt regarding this topic, comment below. I will try to answer as early as possible.